The next stage is to look at the long profile of a river. Long profiles are created by measuring the height above sea level and the distance from its mouth. Invariably, all rivers have a similar sort of long profile, which I will draw for you now. The profile starts off very, very steep. As we come down the valley, it becomes gentler and gentler. And then we go out onto the plain. This can now be used to naturally divide the river into 3 zones: torrent stage, valley stage, plain stage. In each of the 3 stages, 3 totally different things are happening. In the torrent stage, boulders are running down the riverbed very, very quickly. There's a lot of corrosion, attrition, solution going on, and we get a totally different type of valley shape. It's called a V-shaped valley. There it is there, caused by vertical erosion. In this stage, the vertical erosion has largely ceased, and now the river is swinging from side to side in a big open valley. On the outside of the bend here, you're having lateral erosion. Lateral. Remember, a fish has a lateral fin. It's on the side. So we're cutting away to the side. On the inside of the bend, however, something different's happening. At this place here, we're having deposition. This is due to the speed of the water going round the bend. Fast round the outside, slow round the inside. When we get to the plain stage, the river now has very little gradient. It's flowing slowly. The slower a river flows, the more it drops of its load. So this is a zone of very, very broad valleys, huge loops in the river, deposition going on all the time, river changing its course frequently. This zone will be called the floodplain.
First channels to form are first-order streams. When 2 first-order streams combine at a confluence, a second-order stream is formed. When 2 second-order streams combine, a third-order stream is formed. If different order streams combine, the order remains the same as the higher of the 2. So, if a first-order stream combines with a fourth-order stream, the channel remains a fourth-order stream. Other stream order systems show the stream rank rising at each confluence. These explain the size of the river better. However, the stream order can reach into the thousands.
The Bradshaw model. Think about what we've just done, the long profile of the river. This is really common sense. It's nothing complicated about it at all. It's just telling you what's actually happening to the river as you go from the source, upstream, to its mouth, downstream. 3 things down here. Load particle size. Because the river is flowing quickly, it can carry huge boulders, stones, sand, gravel. The channel bed roughness. As you're coming down these V-shaped valleys, it's huge boulders stretched here and there. Slope angle. Posh word for slope angle, gradient. This is the steepest gradient of the river. And as we go down the river from here, the gradient is going to get less. Remember your long profile. But as we go down the river, some other things do happen. The amount of water hitting the river increases. Think about your Strahler model. The amount of channel width increases. The channel depth increases. The average velocity of the river actually increases. Load quantity. Because of the sheer size of the river, it can actually carry more material.
Discharge is measured by flow in metres per second multiplied by the amount of water occupying the cross-section of channel in metres squared to give cubic metres per second. These are known as cumecs.